everyone, I'm Jet Pignano.
And I'm Dustin Go.
So what we're doing today is kind of different. We're actually making a catapult for our AP Physics class. So this is going to be like a build series on like how we're going to build it. Dustin here will talk about the measurements and his drawing that he made.
Yeah, so basically here we have the catapult itself, and the length of it, we're planning to do it as 20 inches. As for like the entire catapult, we can't make it more than 27.5 inches, but we're just taking it less to be safe. For the height itself, as the catapult stands up, we're planning to make it at least 27 inches. And for the length, the width of it, we're planning to make it from 16 to 18 inches. So just to make it good. And then we have two ideas for our locking mechanism, or ways to trigger the actual launcher. We both came up with ideas of having rings to hold down the launcher, and then when we let go of the ring, the launcher, it launches. So yeah, those are our ideas.
All right, and we also have a little model that I built of what the catapult will roughly look like. So what we're doing is we're going to be measuring out the catapult, like rough dimensions on the ground first. So that way we can get a good idea of where to place the metal, then start welding it.
All right, whenever you're ready, I'm recording.
So we just got the 4 pieces of metal cut out, and we're kind of arranged it in the shape of the catapult. What we're going to do now is we're going to notch the middle tubing on these sides right here, the shorter sides. So that way when we weld it, the notch will fit perfectly around the other sides of the tube. First way. So we just got the arch of the catapult all done. What we did is we took 2 of these leftover 90-degree bend tubes, and then we just welded on some uprights and notched them. Dustin actually notched them, which was pretty cool. Then we had to join it in the middle since they're too short, so we just cut a bit of scrap metal and welded that. And yeah, this is what we're pretty much done for the day. We just got the base and then the arch is done. Next week we should be able to work on either the locking mechanism or the uprights that actually hold the catapult arm in place. So I just fully welded the base and the archway of the catapult up. So today we're going to be working on the uprights to which the catapult arm rests, and we'll try to be doing the locking mechanism today as well. So here's the catapult all done. As you can see, we're testing with a Folgers bucket. Unfortunately, that did not prove the best results, and we later changed that to a dog bowl later on. And here's the catapult with the dog bowl change that we made.
As you can see, it has one spring, as this is the short distance for 2 meters. And here's how we had to strategically place the Hackey Sack in the dog bowl in order to ensure like the most consistent results. Here's us testing the 6 meter distance. So we just had a long tape measure out, measured out 6 meters, had our little bucket, and we were just gonna fire.
Ready? 3, 2, 1.
So here's our finished catapult. It can shoot both the long distance of 6 meters with the 2 springs, or the short distance with just 1 spring. We did have to change the locking mechanism a bit. Still use the dual washer design, but we used a metal rod instead of just a piece of string, because what happens was with the string, depending on how hard and what angle you pulled it at, it would affect the results. We also added on a base with an extra weight just to keep down vibrations when it would shoot for the most consistent results.
Let's go, Justin.
I'll grab the 3, 2, 1.
I don't want to sweat in.
Yep. Okay, so I hope you guys enjoyed the build process of the catapult, and as well as testing it and using it for our project in the class. We did pretty well, and I feel like this is a solid design for a catapult. So thank you guys so much for watching. Bye.